Following up on the previous video in which we learned how to solve simultaneous equations using the method of substitution, in this video we're going to be working through a couple more examples using that method, but as we're about to see, solving these will be a little bit easier, as in both cases, one of the two unknowns we need to find, so x or y, has already been made the subject in one of the two equations. That being said, let's get started. Looking at this first example, we need to solve for x and y, and we're given these two equations. 2x plus 3y equals to 9, and x equals to y plus 2. And as I always do, the first thing I'll do here is write SOL as in solution. Okay, when given a pair of simultaneous equations like these, the first thing I do is name or label each of the two equations. So for this first equation here, I'll go ahead and call that E1 as in equation 1, and for the second equation we're given, x equals to y plus 2, I'll go ahead and label that E2. And looking at these two equations, what we notice right away is that in the second equation, E2, the unknown x is the subject. Indeed, we have x equals to y plus 2. Consequently, to solve this pair of simultaneous equations, all we need to do is use the expression we have for x in equation 2 and substitute this expression, this y plus 2 here, inside the other equation, so in this case E1. Here's what I mean. I'll go ahead and rewrite equation 1, but I'll replace the x we have here by y plus 2, since x equals to y plus 2. So let's go ahead. Doing that, equation 1 turns into 2 times in parentheses y plus 2, close parentheses, plus 3y equals to 9. And now looking at this, we notice right away that by replacing x by the expression y plus 2, there's now only one unknown inside this equation, which in this case is y. So we can solve this. Okay, distributing this 2 across this pair of parentheses leads to 2y plus 2 times 2, which is 4. And we still have our plus 3y equals to 9. I now gather the y's that I have here, so I'll have 2y plus 3y, which is 5y. So I have 5y plus 4 equals to 9. Next, since this 4 is being added to the left-hand side, I'll get rid of it by subtracting 4 from both sides of that equation, which leads to 5y equals to 9 minus 4, which is 5. And finally, since y is being multiplied by 5 on the left-hand side, to get rid of that 5, I need to divide by 5, and I do so on both sides of the equation, which leads to y equals to 5 divided by 5, which is 1. And we now have the unknown y. And now that we have y, we turn back to the equation in which x was the subject, so that's the equation I boxed in blue earlier on, and I replace the y I have inside it by the value of y we just found, which is 1. And so I can do that up here, and I can state that E2, remember that was the equation we boxed in blue, becomes x equals to 1 plus 2, in other words x equals to 3. And we're done. We've just solved this pair of simultaneous equations for x and y. And of course we could check these results. Indeed, looking at this first equation we have here, if we replace x by the value we found, which was 3, and y by 1, this becomes 2 times 3, which is 6, plus 3 times 1, which is 3, so that's 6 plus 3, which is indeed equal to 9. And for the second equation here, replacing x by 3 and y by 1 again, we get 3 equals to 1 plus 2, which is indeed true. So these are definitely the correct solutions. That being said, I look at the second example. Again, we need to solve for x and y, and we're given two equations. The first of which, y is equal to 5 minus 2x, and the second one we have 3x minus 4y equals to 13. And again, I'll go ahead and write SOL for solution. Once more, I start by copying these equations and by naming them or labeling them. So y equals to 5 minus 2x will be E1, and 3x minus 4y equals to 13 will be E2. Looking at these two equations, we quickly see that in equation 1, y is the subject. Indeed, we have y equals to 5 minus 2x. So, using E1, we can substitute the expression we have for y, so 5 minus 2x, inside the other equation, so in this case E2. And so we'll replace the y we have here by 5 minus 2x. And in doing so, that second equation, E2, becomes 3x minus 4 times, in parentheses, 5 minus 2x, and that's equal to 13. And looking at the equation we have now, we can see quite clearly that it only contains one unknown, in this case x. So we go ahead and solve this. Okay, well let's see, I'll start by distributing the 4 across this pair of parentheses. So this becomes 3x minus, in parentheses, 4 times 5, which is 20, minus 4 times 2x, which is 8x, and I close those parentheses, and that's still equal to 13. And now, since this pair of parentheses is being subtracted on the left-hand side, as I open them up, everything I see changes sign. In other words, this becomes 3x minus 20 plus 8x, and that's equal to 13. I carry on. Gathering the x's we have on the left-hand side, we'll have 3x plus 8x, which is 11x, and we still have this 20 that's being subtracted, so that's 11x minus 20 equals to 13. And now to get rid of this 20 which is being subtracted from the left-hand side, I add 20, and I do so to both sides. So this becomes 11x equals to 13 plus 20, which is 33. Last but not least, I need to get rid of this 11, which is multiplying x, and I do so by dividing 11x by 11, which tells me that I must divide the right-hand side by 11 as well. And so we get 11x divided by 11, which is just x, and that's equal to 33 divided by 11, which is 3. And we've now found the unknown x. And so now that we know what x is, we turn back to the expression we had for y, that's what we had boxed in blue here. In other words, that was equation 1. And in fact, I'll do that over here with a little arrow there, like so. And I can write that E1 turns into y equals to 5 minus 2x, but since x is equal to 3, that becomes y equals to 5 minus 2 times 3. So that's equal to 5 minus 6. And finally, y equals to 5 minus 6, which is negative 1. And that's the answer. We've now solved this pair of simultaneous equations for x and y using the method of substitution. And there we have it. That's it for this second tutorial on solving simultaneous equations using the method of substitution.